In this chapter, we're going to be learning about probability distributions. So I want us to recall first that we learned about discrete variables. And a discrete variable is usually a variable that is representing a count. So it's quantitative, right? We're still looking at numerical data, but it represents a count of a number of objects or number of individuals. So what we're going to look at here is how to do a probability distribution for a discrete variable. We are going to, basically a probability distribution means we list each possible outcome and then we list the probability of that particular outcome. As a reminder, probabilities have to be between 0 and 1. We learned that in the last chapter. And the sum of all possible probabilities must equal 1. So if we look at every possible outcome, the sum of those probabilities for each outcome has to be 1. So we're going to go ahead and start with an example of creating a probability distribution. And the example that we're going to look at is we're going to make a probability distribution for the possible sums that occur when you roll 2 dice. And so I'm going to start over here. We're actually not making the probability distribution yet. We're just first going to analyze the possible sums that occur when you roll 2 dice. So I want us to think about this. If we roll 2 dice, and let's use different colors to make sure that we get a better picture here. So let's say that one of those dice is purple. Then we could have on the purple die, we could end up with a 1, a 2, a 3, a 4, a 5, or a 6. And then let's suppose that our other die is gray, and on the gray die we have the same possible outcomes, either a 1, a 2, a 3, a 4, a 5, or a 6. And so when we look at the possible sums that could occur, if we get a 1 on the purple die and a 1 on the gray die, 1 plus 1 is 2. And so that would be a possible sum of 2. That's the smallest possible sum. The largest possible sum would represent a 6 on the purple die and a 6 on the gray die. That would give us a sum of 12. And every possible sum in between 2 and 12 is going to be in there also. So it's possible to have a sum of 3, 4, 5, 6, 7, 8, 9, 10, and 11 as well, and along with the 2 and the 12. So what happens if we're not careful is when we start to make a probability distribution. So a probability distribution, we list the value of x, again where x represents the sum, when we roll 2 die, and then the probability of x. Well, we just talked about the fact that that sum can take on any value between 2 and 12 as long as it's an integer. And so our possible sums are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. What we have to be careful with as we're creating the probability distribution is that the probability of each of those outcomes is not the same. So it's tempting to look here and say, well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 possible sums. And it's tempting for people to say, well, then the probability of each one is 1/11th. But we know that's not true, and that's why we're going to make this table here of the possible sums. If we were doing something like flipping a coin and looking at the probability of heads versus tails, well then the probability is 0.5 of heads and 0.5 of tails, so those have equal probabilities, but not so for the possible sums. So if we kind of go through and fill out the possible sums here, if I get a 1 on the gray die and a 2 on the purple die, that's a sum of 3. And just continuing here, again, these numbers represent the possible sums. And so what we see is that when we roll a pair of die, we have 36 possible outcomes. Now, there are certainly some events that result in, or some outcomes that result in the same event. For example, if the event is rolling an 8, well, there are 1, 2, 3, 4, 5 different outcomes that give us that same event. But the way that we roll an 8 might be different. So over here I had a 6 on the purple die and a 2 on the gray die, whereas over here I had a 4 on the purple die and a 4 on the gray die, right? So you can see there are different outcomes that can make up those same events. So when I look at the probability over here of having a sum of 2, well, there's only one way out of the 36 possible outcomes that could occur. So we have 1 out of 36. But rolling a 3 is going to be a little bit more likely. There are 2 ways out of the 36 to roll a 3. And then we continue. There are 3 ways out of the 36 to roll a 4. There are 4 ways to roll a 5, 5 ways to roll a 6, 6 ways to roll a 6 ways to roll a 7. And then we're back down to 5 ways to roll an 8, 4 ways to roll a 9, 3 ways to roll a 10, 2 ways to roll an 11, and only 1 way to roll a 12. And again, when I'm saying roll a 12, roll an 11, I mean a sum of 12 or a sum of 11. Okay, so this over here to the right is our probability distribution that we were asked to make. So it lists the possible outcomes and then the probability of each possible outcome. As a reminder, that probability column should sum to 1, and it does, right? 36 out of 36, which is 1. All right. So what we're going to look at next as we continue here is how to calculate the expected value for a discrete variable, which is basically its long-term average, its mean. And so basically we're trying to figure out long-term average. If I roll a pair of die, what's the average sum that I would end up seeing? Okay. We also can find the standard deviation of the variable of interest, and so we're going to look at that on the next page. Okay. So here what we have are formulas for finding the mean of a discrete probability distribution function, and then the standard deviation. And so we're going to look at examples of both of those for the same die example we just did. So here, if we want to find the mean or the expected value for the variable sum when we're looking at an experiment of rolling 2 die, so this is what we just did. If we look up here, it says the way to find that mean is to multiply each value of x by its probability and then add all of those up. So for our case, the mean is going to be calculated by taking each of the observed x values, multiplying it by its corresponding p of x value, and then taking the sum. And so this is gonna be a little bit tedious, but we're gonna have a sum of 2 had a probability of 1 out of 36. And we're adding, right? The formula shows that we're taking the sum of each x value times its probability. So a sum of 3 had a probability of 2 out of 36. A sum of 4 had a probability of 3 out of 36. A sum of 5 had a probability of 4 out of 36. A sum of 6 had a probability of 5 out of 36. A sum of 7 had a probability of 6 out of 36. A sum of 8 had a probability of 5 out of 36. A sum of 9 had a probability of 4 out of 36. A sum of 10 had a probability of 3 out of 36. A sum of 11 had a probability of 2 out of 36. And finally, a sum of 12 had a probability of 1 out of 36. So again, I know that's a lot. If we go through and try and find this mean, 2 times 1 out of 36 is 2/36. And then we have 6/36 and 12/36 plus 20/36 plus 30/36 plus 42/36 plus 40/36 plus 36/36 plus 30/36 plus 22/36 plus 12/36. And so if we add all of those 36 up, and that's why you'll see I didn't reduce any of these fractions because I wanted to keep that common denominator. We have a numerator of 2 plus 6 plus 12 plus 20 plus 30 plus 42 plus 40 plus 36 plus 30 plus 22 plus 12, which is 252. And 252 divided by 36 gives us 7. And so the mean or expected value is 7. And what we're saying there is that is the long-term average sum that we should expect if we're rolling a pair of die. So if we're rolling 2 die and we're observing the sum that occurs each time and we average out long-term the sums, on average the sum will be 7. Okay, I'm going to show you in just a minute how we can do this mean and the standard deviation much faster using the calculator. Okay, but I want to show you by hand first. So the last example here is we're going to find the standard deviation for the variable sum. So here's our standard deviation formula. We need to take each observed x value, so each sum, minus the mean that we just calculated, which was 7, square those values, then multiply them by their probabilities, add them all up, and finally take the square root. So that's going to be our process. I'm going to do this using a table. So we're going to need to take x minus mu, right, from here. We're going to need to square each x minus mu value. We're going to need to multiply it by its probability. And then those are what we're going to add up and then take the square root of eventually. So it might help us to add in an x column so that we make sure we remember what variable we're, or what observed value of that variable we're looking at. Remember, x is our possible sums, so we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so those are our possible sums. Our mean, remember, we just calculated was 7, so this column is going to be each x value minus 7. So I've got 2 minus 7 here, which is -5, and squared is positive 25. So we're going to just fill these in as we go. 3 minus 7 is -4. Squared is 16. 4 minus 7 is -3. Squared is 9. 5 minus 7 is -2. Squared is 4. 6 minus 7 is -1, squared is 1. 7 minus 7 is 0, and 0 squared is still 0. And then we're going to continue. This one happens to fall in a pattern. We're going to continue. 8 minus 7 is +1, squared is 1. 9 minus 7 is 2, squared is 4. 10 minus 7 is 3, squared is 9. 11 minus 7 is 4, squared is 16. And 12 minus 7 is 5, squared is 25. And once we have each of those values, we need to multiply the x minus mu squared value by its probability. So again, that's the probability of observing a 2. So if you remember back from the previous page, the probability of observing a sum of 2 was 1 out of 36. So we're multiplying 25 by 1 out of 36. And then here we're multiplying 16 by 2 out of 36. And here we're multiplying 9 by 3 out of 36. And 4 by 4 out of 36. And 1 by 5 out of 36. 0 by 6 out of 36. 1 by 5 out of 36. 4 by 4 out of 36. 9 by 3 out of 36. 16 by 2 out of 36. And finally 25 by 1 out of 36. And so I tried to leave room right next to this so we can actually do that multiplication. So this would be, I'll just do it here, 25 36, just multiplying. This would be 32 36. This one's 27 36. 16 36. 5 36. 0, 5 36, 16 36, 27 36, 32 36, and 25 36. So if we sum all of those together, then out of 36, let's sum all those numerators together. We will have 25 plus 32 plus 27 plus 16 plus 5 plus 5 again plus 16 plus 27 plus 32 plus 25, and we get 210. 210 36ths. Remember, that is the sum of the x minus mu squared values times their probability. And so last we need to take the square root of that. So our standard deviation is going to be the square root of 210 over 36, which we can find here. So the square root of 210 over 36 gives us 2.415 if we round to 3 decimal places. And so what we're saying here is that this is the average distance of each of those possible sums from the mean of 7. So on average, we're going to roll a pair of die and get a sum of 7 with a standard deviation of 2.415. And I did let you know that I would show you how to do this really quickly on the calculator, so that's the last thing. So the way we're going to do this on the calculator is we're actually going to go back to that probability distribution function that we created. And we are going to go into our calculators and go to our lists. So remember, that's under stat. I'll do it over here. So stat, edit, and into list 1, I already put the data in here. But into list 1, you are putting your possible values of x, so 2 through 12. So you can see I already entered those in there. And then into list 2, you're putting the frequency, so the count of each of those values. So basically it's the numerator of each of those probabilities. So there's one way to roll a sum of 2, there were 2 ways to roll a sum of 3, etc. So we have 1, 2, 3, 4, 5, 6. Rolling a 7 as our sum was the most likely outcome with 6 different outcomes there. And then back on down to 1. So you've got, again, your observed values of x in list 1 and your frequencies in list 2. From there, you're going to hit stat, calculate, one variable, stats, and make sure that in list you have L1. That tells you where your data values are, your observed values. And you want to put L2 here in for frequency list. So you probably have nothing there. It's just blank. And so you'll want to enter L2. So that is second. And then L2 is the second function right above the number 2. So we're telling it that these were the observed values, but they occurred with frequencies that we typed into L2. So in other words, the sum of 2 occurred once, the sum of 3 occurred twice, the sum of 4 occurred 3 times, etc. And then hit calculate. And you'll notice that it gives you the mean x bar, which is our mean here. We use the population mean notation, so this is 7. That's the same as you'll get here. And then you can see our standard deviation. This is, again, a population standard deviations calculation, so it's the 2.415, which was what we got when we did it by hand. So you are welcome to use the calculator as a shortcut as long as you understand the process.